What's up, YouTube? In today's video, we're going to be looking at value tuples primarily, and this is a new feature since C# 7.2 or something. But we're also going to be looking at anonymous types, which have been around since LINQ has been around, and tuples, which are the older version of value tuples, but focusing on value tuples and focusing on going under the hood. So this is so you think you know C# series, so you can imagine there's lots of surprises here waiting for you. So if you don't know how some of this stuff works under the hood, then this is the video for you. With regards to value tuples and even anonymous types, maybe some people use them, but they don't quite understand like what's going on. And that's the point of these series, the C#. So you think you know C# series. Focusing on value tuples, first we need to understand where would you use them, then understand what they are, and then go under the hood and try and understand even better or even deeper what they are. While we do that, we might also be looking at anonymous types because there is some similarity to some extent, just again, from an interest point of view, think you know C# perspective. Understand what anonymous types are, contrast them with value tuples because they kind of seem the same, similar. And also the old tuple types, which also sort of satisfied the same need that value tuples do today. And in many ways, the tuple type, the old tuple type, is considered a mistake now. Of course, 2020 hindsight. So first, just let's look at where would we use value tuples, right? So first of all, value tuples, they're called value tuples because they are value types. They're not reference types. The tuple type, which has been around for many more years, is a reference type. But otherwise, both of them look kind of the same. The difference is one is value type, one's a reference type. Now it's a struct. The value type tuple is a struct. And typically in C# the guidance is that value type should always be immutable. And whenever you design your own structs, your own value types, please make sure they're always immutable, as in they are not mutable. However, value tuples are mutable, and that's something to be careful about. There's probably a reason for why they're mutable. But as a result, you need to understand that they are still value types. They are not reference types. And value types, mutating value types has a different behavior from what I think most people are used to when they mutate reference types. All right. So having said that, when would you use these tuples, value tuples? Essentially, when you want to return more than one argument, more than one variable from a method. Right? So typically methods have one return type. Sometimes you want to return three return types. And the tuple type in C# has been the sort of the stand-in for that. And of course, there are some issues with the tuple type, and I'll discuss those. And as a result, nobody ever used them. So the value tuple looks similar to the tuple type. So what's so special about them? Well, that's what we're going to find out today. So here I'm going to design a method that I would like to be able to return multiple types. So we'll leave that. Let's call this compute aggregates. Let's say, and the aggregates I want to compute are things like sum, average, and max, let's say. So I want to return multiple types. So I'm going to do that. Let's do this with the tuples first, the older tuples. So yeah, the tuple, the sum, let's say I'll keep them as double. Sum, average, also double. And let's say max is an int, just as for argument's sake. All right. Okay. So if you were to return this, some type from here, then you would have to say, return. And I believe tuples have a factory dot create. So you can use this, dot create factory method, and you can specify the different types, or you could just simply, if you know them to be doubles, right, you could say, let's say, count, let's say 20D, the double, and then they have it, let's say 13D, and the max is, let's say 35, as an example. Right, so I can return this. I'm returning an instance of a tuple. This is not the value tuple, this is the tuple type. And over here, let's say we were looking at using this, that is return compute aggregates, right? You would have something like that. And when you look at the aggregates type, you'll see there are properties. It's called item 1, item 2, and item 3. It's not called sum, average, and max. So that was the problem with the tuple type, that even though we could conceptually return multiple values from a method, rather than you defining your own type, this tuple thing kind of made it quick and simple or easy, convenient to define a thing literally kind of on the fly without having to specify your own type, right? The problem was that item 1, item 2, item 3 didn't make sense on the call side. And you kind of lost that usability, if you will. Personally, and for even with people I know personally, we hardly ever used tuples. In fact, never. Right? I tried it once literally and I gave it up. I said, okay, this is it. I don't like this item 1, item 2 thing. I'm just going to define my own types. One would wonder then, so what's the real problem? So you can define your own types, and I'm never, believe me, I'm never concerned with defining extra types. I'm really not. But I do get concerned when the extra types really don't have any meaning to my business. You know what I mean? Like if I define a type that has a sum, average, and count, like it doesn't necessarily mean anything to me. It's not, I can't give it a name. It's not a sort of basic, domain entity in that sense. It's just a thing. So now I start questioning, do I want to define things like that, that have min, max, and count, and average, sum, that I can't actually name at the business level? What do I do with this stuff, right? It's like I'm defining things that don't really hold a whole lot more in meaning than what they just are. And that's when I would wish I could use the tuples, but I didn't want to use tuples because of the item 1, item 2, item 3 thing. So if you find yourselves wanting to return a domain specific thing, or that in your mind could be considered part of your business, your domain, the system that you're building, then don't use value tuples, right? Just use them for these kinds of things that are a grouping of certain values that you would like to return from a method. I mean, it makes sense, right? You got a collection of, information. With one iteration through this collection, you can calculate the sum, you can calculate the average, you can calculate the min, you can calculate the max. It makes sense that you can do all of these things in this one method at the same time. And what if you could just return them, right? Now, you can do that today with out and ref modifiers. But as for the guidance, don't use out and ref modifiers. And so we would resort to defining our own types. Okay, so let's look at what else can we do with the tuple. Let's say we use value tuple here instead of this type. And you say, okay, then value tuple also has a sort of a factory method, if you will. It does that. And now what's the difference here? Let's see that. What's the difference here? Well, it's the same thing. Item 1, item 2, item 3. So like, where's the benefit? What's the value? What's the value of value tuples? There doesn't seem to be a value, but it gets better now. So now that you understand through the use case and some of the problems with the tuple type, I'm going to introduce to you the value tuples, and we're going to look at how best to use them. So with the value tuples, this is not the syntax you would use. You would actually use something like this. So there's a lot of convenient syntax when it comes to value tuples. So you would do that. And you're saying, hey, but that's great, Jay. How much did that save us? Well, it gets better. You can actually also do this. Right? And so what you're doing is you're saying, here's the definition at the time of defining the method signature. You're saying this method returns a double int. And then it returns this as a single thing. And then it seems to have put them all together here. You can't remove these parentheses. The parentheses are required for a reason, and I'll show you what that reason is once we look at what's going on under the hood. It's just going to make sense. On the call side, then, what's the difference? Let's look at the difference on the call side. Well, we're still stuck with item 1, item 2, item 3. So we're getting a little better. The definition of the method is a bit improved. The return type is a bit improved. You have to specify the new value type and all that over here. So value tuple, I mean. So what's so special? There are a couple of things. One, I'm going to now, even though for the sake of this exercise, I felt it's easier to work with something more meaningful rather than abstract, like sum, average, and count. Like they're all just numbers. It doesn't really make a lot of sense. So for the sake of explanation only, I'm going to use a vehicle DTO, vehicle, DTO, because it's got like a make, model, year, and then it just has a little more meaning. But don't do that in your systems if that's your business. As in, vehicle has a meaning, then define a type called vehicle. Don't use it as a tuple or a value tuple, right? So I'm going to have this change this method called get vehicle, and the make would be a string. The model also will be a string, and let's say the year is an int. Okay, that was already an int. All right, so here, let's say the make is Mercedes. The model is AMG SLC 43. Who likes this car? Oh my gosh. And this is the 2020 model. Oops, 2020 model. Okay, we have a Mercedes here. And we do that. So I'm just bringing it back to the way it was before, except now with vehicles instead of aggregates, all right? So far, we're not seeing any difference. We're still seeing the item 1, item 2, item 3. That's great. All right. So where's the value of value tuples? What are we really getting as a benefit? And what's going on under the hood, right? One value is you can do that. You can do that. How cool is that? What it really means is the first return type will be assigned to this local variable here, the second return type over here, the third return type over here. And of course, if you were to look at the values, you will see, let's say if I just did, type print out the make over here. Yeah, we should see Mercedes as the first return type here. Right? And you see Mercedes, right? Okay, so this idea or this ability to split up the return type on the call side into multiple variables is called deconstruction. And it's also a feature of tuples. We'll be looking at that. It's not, sorry, what I meant is it's not only a feature of tuples. So we'll be looking at deconstruction for other types that you might have in a system as well, because it's a very powerful and very cool feature. Of course, everything cool ends up getting abused. And then I fear every time I show you something, next thing you know, it's going to get abused. So please use them wisely. But this is the idea of deconstruction, and we'll be looking at that. So this is using deconstruction. It's able to take a return type like this, or multiple return types, and allow you to deconstruct it like that, right? There's another way you can do that. The var is, of course, type inference based on the return types here. So it's inferring the type, right? So now you might be wondering in some cases, what's the difference between the tuples then and anonymous types? They seem to be similar. If you've used anonymous types, you're wondering like, that's almost like anonymous types, right? So here's what anonymous types look like. So you could have something, let's say vehicle, and you could say new could say make. AMG SL43 2020. Oops. All right. And then here you could get access to the properties, the make, model, and the year, right? With anonymous types. And well, the value types, let's say we didn't call this method, I could do this with value types. Value tuples, I don't mean value types. Value tuples. So here I could say Mercedes AMG SL43. Oops, 2020, right? now they start to look very similar, these two. So let's look at anonymous types just for a bit. I think I don't want to spend a whole lot of time on it, but there's some magic happening with anonymous types as well under the hood, since this is again so you think, C# series, it's worth it digging in a little bit under the hood to see what the heck is going on with anonymous types, right? I'm going to remove this part for now. And remove that as well. So I just want to show you this part. What happens with this, right? I'm going to go, I've compiled this application. I'm going to go into ILSpy. I've already hooked up the XZ to ValueTuples to ILSpy. So I'm going to keep doing this over and over. And here we shall see some magic. All right, what the heck is that? Do you see this? What do you think that looks like? This looks pretty weird, but really this looks like the type name. That's a generic type. So now this is a closed generic type. It's called VAH, and they're saying new of that closed generic type. And then it's got our data here. So even though we wrote just this code, see this with new curly braces and all that, it has basically lowered. If you remember the C# lowering, if you don't know what C# lowering is, please take a look at my video here. I talk about C# lowering. It's a very interesting feature if you're wanting to understand how the C# compiler works, what's going on under the hood, stuff like that. That'll be an interesting video to watch. This is C# lowering. What it's doing really is this taking the code we write here, which is like a convenience feature, and it translates that to normal C#, which is it has to new it up and stuff like that. But what the heck is that? If you look at this one, it is an internal seal class that's got this funky name. And look at the names of these things. Holy my gosh, goodness. Thank God we don't write code like that. If any one of you writes code like that, I tell you, I'll look for you. I will find you. Okay, the thing is, this is bad C# code. We are not able to write code like this. The compiler will block us from naming our variables with open angle brackets and underscores and stuff. But it's still valid C#. We're just not allowed to use that. And so as a result, whenever the compiler generates C# code on its own, it uses this naming kinds of things because it knows there will never be a collision, right? It has to be free of collision from its own code that it generates, as well as from any code that we might have written in our application. So that's the name of the class, all of that. And then there's this part here. And then these are the generic type arguments, the names of the generic type, like T1, T2. So that's they're given these weird names to them. And then you have read-only members that have the, funky names again, and the types. So that's the name that's the type. And then that's the name, make, model, year. So it's using the previously existing names, but adding some other stuff to it to kind of make it, unique. And then it's got properties defined, and then a constructor that takes those arguments and so on and so forth. It also overrides the equals and get hash code. So with the value tuples, so this anonymous types, with anonymous types, they are value semantics. They use value semantics for equality or your value equality, not reference equality. So because they've already written the equals and get hash code methods and also the toString implementation, all that is done for you. But this is a type it creates on the fly. Right? It didn't exist. There was no base class. There's no base class here. It's not descending from something. It just manufactured this type all on its own. It's pretty cool. But it's a reference type, which means anytime you use value types, you're creating a reference. You're creating a new instance allocation on the heap. So you'd be worried about that. If you're using this in link, especially when you use, select and you project some type doesn't pre-exist. If you do that a lot, you might as well just define the type yourself, right? It's not adding any value to do this sort of thing on your own. But here's another thing. Let's say I might have I define this multiple times, not just in the one next to each other, but elsewhere in my application, like anywhere else, right? If I made the same declaration here, same property names, whatever model, the values are different, but the property names and the types are the same, then at compile time, the compiler will not generate another type for this one. If they match, you'll just use the same type. It's a type definition. Why would it define another type that's exactly the same as this one? So if it finds that the type definition already exists, it won't define a new type definition and a new type. And so you'll benefit to some extent where, reusing anonymous types. All right. So far, it's just been anonymous types, but I'm done with anonymous types. I'm going to go back to the value tuples. All right. Okay. So going back to value tuples. Okay. So we had this thing here, and you're wondering like, okay, but what's the deal with this? What if I did that, right? You can also do this. And if you're defining the thing here, you could do, make something like that. I believe the syntax. Yep. If you're defining something on the fly, and this one makes sense, but that's not how it normally works. So now when you do vehicle dot, you'll see the make, model, and year going on here, which is cool. So this is very unusual, right? You don't know this ahead of time. So it's not normally it's coming from a method here. So let's go back to these method type signatures and how would you define these method names, method signatures. All right. So now we just remove that, put this here. All right. At this point here, we're still stuck with the item 1, item 2, and item 3. And we are going to look at now how to improve on this. So one way to do that, as I showed you earlier, was you can deconstruct it here. And you can do that. So you're doing the deconstruction. And apparently you as the caller, that method seems to know what the different types are. The string, int, like what's the first string, what's the second string, what's the third string. You now have to look at the implementation of the method, right? You can't discern this from the outside. So you have to look at the implementation to understand what's the first string, what's the second string, what's the third string. That's okay, but I don't recommend that. So what you can do also, you could have, when you define this method, you could say the string is the make, and then this is the model, and that's the year. Now, notice the casing is unlike the sort of argument casing, right? In arguments, in C#, we would normally name them as camel cased. This is more Pascal cased, the return types. The reason is when I see it over here now, even if I did this, right? If I did something like that, I could look at and see that there now has the make, model, and year properties. And the casing here, the way I'm seeing them is because of the way it's been defined over here, right? If I define this in camel casing, then that's what I'm going to get. So I'll leave that up to you to decide whether you want to make these as camel cased or Pascal cased. One is I think it might make it easier. This doesn't look like method arguments, the return types. So maybe that would be a benefit to disambiguate the inputs and the outputs. Because on this side now, you're going to see this as Pascal case. So you got to make, model, and year. That sort of seems or looks weird. So I would actually prefer to do that. Right. You can still deconstruct it here, so you don't have to know that. This is more from the way you define the method signature. I'm talking about that as a perspective of, for the sake of understanding the method signature in and of itself, that's how you should do it, right? You should always define the type and the name of the argument so that people from the outside of the method don't have to look at the inside, the implementation to understand what is that first argument, what's the second argument, what's the third argument, right? The other thing is, don't use this feature for methods that require to return more than 3. I think 3 is the max. 3 is already, I think in some cases, too much. 1 and 2. 1, of course, we already had. 2 is when you start to use value tuples. And 3 is kind of the limit, I think. If you start using value tuples for more than that, it gets really complicated and hairy to understand what is going on. But also, the readability. I mean, especially when you're using generic types, right? IEnumerable or task of this, of IEnumerable or something else, and that one argument is that long, and then like by the time you finish 2 arguments or 3 arguments, you've gone past your width of the screen. Just in the output arguments, you've not yet defined the method name and the input arguments. So, but I think if you go beyond 2 or 3, look at, do you want to just define your own type, right? Again, the type, sometimes I have an issue with defining types that are not quite meaningful to my business side. They're simply placeholders or a way to combine multiple values. But if it means that the readability would improve, then I would certainly look at defining a type that's named somehow correctly for the thing I'm trying to do here, and then use that instead of more than 3 return types in a method. I think that 3 is like kind of a limit, right? Okay, so the other option is, as I said over here, you could still go back and define it, be more explicit, and you could do that. And you could define a variable over here, which you can't normally do if you don't specify the types. If you use var, you can't define a variable. In other words, let me just copy this over and I'll keep writing this over and over. If I did that, then I won't be able to define a separate variable on top of this, right? This doesn't work. At this point, it doesn't like this. I have to remove this type here, and now it works, right? So you can do this, define your variable, local variable like this, or instead of using var, you specify the types of the arguments and the names. And then on top of that, you can also specify a singular variable so that your singular variable's properties will be equal to what you define. So now overrides, this is lowercase maker, it overrides what is coming from the method. So this is the thing with the magic. As I said, value tuples under the hood are simply, we haven't seen what's going on under the hood, right? Let's look at what's going on under the hood with value tuples. All right. So now I've built it. Let me compile. Sorry, refresh this assembly here, reload it. And let's try it again and look at if we look at main, that looks different, but it's understandable. If we are saying it's a type value tuple of string int, call it vehicle, and then look at this. So the way we written the code with the assignment as make model year, it gets rewritten to that. It defines it as a vehicle of tuple string int, but then it assigns local variables with the names and puts them in here, right, at compile time. What happens to this method here? Now in the methods, this is the one aspect of value tuples, is there is a concept called type erasure. Type erasure is typically associated with generics. For example, in Java, the generics is implemented using type erasure, which means once it's compiled, you lose information about the type, right? The constraints that you're limited with are only for compile time, as in at the time of you writing the code and compile time. Once the thing has been compiled, those constraints have been removed. So in other words, there are features in languages that prevent users, people who are writing code in that language, from doing certain things, yet the language itself doesn't have a constraint. And so type erasure is this idea where, like in Java generics, you have certain constraints when you're writing the code, but once it's compiled, those constraints disappear there. So the type information, if you will, disappears. It's not actually required for runtime, but it is required at the time of compiling. C# generics, of course, does not use type erasure. It uses the opposite of type erasure, called reification. I think it's pronounced, spelled as R-E-I, reification. I don't know how you say that, but that's what it is. And that's the way C# generics are implemented. In value tuples, we have a notion or a semblance of type erasure, whereas certain information that we had at compile time disappears after compilation, and that's what it is over here. We've lost that information about the names, and so what they've done is they've introduced, by names I mean, like if you look at here, we have given the names for the return types. And so what they've done is they've introduced another attribute here called tuple element names for the return types, as just names. So if you were to reflect upon this assembly here, it's not going to be simple for you to reconstruct, if you will, the idea that these things were called these names, but it's possible. Right? So with the help of the attribute, that type erasure is reinstated, if you will. But for all practical purposes, the type erasure has taken place and you don't actually know what the thing is. It's still value tuples. All right. So behind the scenes, just to recap here, the method signature changes to still go back to value tuples. The implementation is still saying new value tuple, blah, blah, blah. And now you understand why that signature warrants us to have to write this code here. Because this is the way to create a new instance of a value tuple where That's the first argument. That's the second argument. That's the third argument. I wonder if this would work. Oh, that'll allow that. I guess it does. What does that do? What if I didn't specify this? Doesn't like it. So as long as this is the match, it's good with that. Yeah, as long as the name matches, it's good with that. So basically that declaring it twice doesn't have any meaning then. Okay. And these guys think about everything, don't they? Okay. Oops. Right. And because these things are value types, be careful about something like this. Let's say I have, this is so-and-so, and I'm going to go back to declaring this. With the types we have, I will need that variable. All right. And let's call this. Okay. So when you do this, this is a copy. It looks like this is an assignment, like, you assign reference types to each other. This is not the kind of assignment. This is a copy. Right? So there's a new instance of this value tuple being created here as of course, the value type. And so you're making another copy of it. These two are not the same. Right? So if you then modify the properties of the one that's copied or the original one, there's no connection between these two things. They don't share the same reference. So keep in mind, even though it looks like, reference types is something you want to do. So of course, when you're using value tuples, personally, if something comes back to you from a method, you shouldn't be changing it. So similarly, when a method receives something, you shouldn't be changing it. So if you program like that, it's not odd or unusual for you to not touch it. I know a lot of people kind of don't like to declare the variable, and so they start modifying the variable that came back from methods or sent into methods being changed by the method. So don't do that. But if you are doing that sort of thing, then be careful of these being value types and not reference types. And as I said, that these are value types, they're also mutable, meaning I can actually change the property. So let's say make to something else. Let's say I said, that's allowed. It will allow me to do that. It's not going to create a whole new copy. It's the same copy, same instance of this value type whose property make has been changed from Mercedes to Toyota. Right? It's not a new copy. So it's mutable. I'm not sure why it had to be mutable, but yeah, be careful of that too. In case you're used to things being immutable, I am, and these things can be mutated, then just be careful of how you use that as well. The other thing that may not have been apparent here is when you look at the the value types, they implement the equals and the get hash code methods here. So, which means that these value types, value tuples, you're able to compare them using value comparison, value semantics, so unlike reference semantics and reference types. So that's also a key thing to keep in mind, that you can compare these as A equals B, meaning all the property names and values are the same. That if not the same, then they're not equal. If not, they are the same. Right? Structural / value equality. So the fact that they implement get hash code of their own as an overridden gives you the ability to use these things in dictionaries as keys. Equals with the equals method allows you to compare using value comparison or value equality. And the same goes actually for anonymous types as well. They also implement the equals method in the anonymous types, the generic, that class they define on the fly has that implemented, and also as the toString also is implemented in that class, and so is get hash code. So even anonymous types can be used in dictionaries as keys, can be equated or compared with the value equality semantics using the equals method and so on. So then the last point is deconstruction. Okay, so deconstruction is how this stuff works. All the stuff that we're able to do here is deconstruction. But what if you want to be able to do this for your own types? Yes, you can. You can also do this for types that you don't own using intent extension methods. Right? I personally wouldn't suggest it, but again, it's a cool feature. So if you have your own types, you could do that. So let's see how that would work for our own types. Right? So I'm going to define my own type here. Let's call it vehicle. And let's call this, and this is the string. Okay, so this is just an immutable type. So I have my own type here. It's just something I'm going to call it vehicle, and I want to be able to use it. So let's say I want to say, how do you have vehicle there? So just say v is equal to new vehicle, and let's say over here I'll say mg SL43 2020. Right. But let's say I return a vehicle type from another method, and this vehicle, of course, it's got 3 properties, but let's say this type had a whole lot of properties. However, most times when people use your type on the call side, even though they'll have a need for all of the values, they typically use, let's say, 2 or 3 of these values for the most times, right? So you could say, okay, I'm going to have a deconstruct method. You can have multiple, by the way, not just one. In the same class, you can have multiple deconstruct methods by the same name, deconstruct. And that's, you want to know what that is? How does that work? Just because I could define a method with the deconstruct name, like how does that happen? Duck typing, yes. So C# has some duck typing in that regard as well. If you looked at I forget which video I talk about, with 4 each also, there's duck typing and so on. So there's duck typing kind of finding its way in different parts in C# as well. It's not necessarily that we use duck typing, but the compiler and the runtime could possibly use it. All right, so I'm going to go here, and in my vehicle class, this is my own class, but I'm going to define a public method. Oops. This is a void returning method, but it's got out types. So this is out modifier, out string make, because this will be camel case now. Out string model, camel case now. It doesn't have to be, but I'd rather stick to the convention that we have in C#, which is arguments are camel cased. Okay. And here you implement it. So you have to actually implement it. So let's say over here, we'll say, make however you implement it. I mean, it's like at some point you'll have to assign the values before the method leaves. So on the call side, now that I have a deconstruct method here, on the call side, I could basically do the same thing. I could just say var make model and year. And that works. It works because of the fact that this class has a deconstruct method on it, right? As I said, you can have multiple deconstruct methods in a class. You got to be careful about the ambiguity aspect, even though C# does not determine whether a method is the same or not based on return types. The ambiguity on the call side can occur based on the types of the values returning. So be careful about it. Not careful. Something may not work the way you expect because the compiler might, on the call side, might complain about certain things. And the other thing is that you can define on using extension methods, deconstruct methods on types that are not yours. So, if you feel like you're using this one type that you have in your system a lot, It's not your class, it's coming from some other library. You could define a deconstruct method on it for yourselves, and you can use them with the 1 or 2 arguments that you use normally. And that's kind of like a convenience way of doing it. The other aspect about these types is that, let's say in this particular case, I'm not interested in the year. So I don't even have to define the year parameter or argument here. You can use the discard. And the discard is sort of showing intent. You're saying, okay, in this particular case, I'm only interested in the make and the model. I don't care for the year. So no need to declare the variable year, just not to use it. Just don't use it, declare it. So it's discard. It's called a discard in C#. And of course, they can all be discarded if that's what you wanted. So I'm saying in this case, in this particular case, let's say I'm calling this method and it returns to me a vehicle. I'm only interested in the make here. Maybe somewhere else I'm interested in all 3, but in this case, I'm only interested in the year. Right? So I'm discarding or using the discard type in C# to discard. And that's not, you can't do that. So if I want to discard something like from a return type, I can also discard it as a singular. But that doesn't make sense if I discard it like that. Like, oh, oops, sorry. Where am I? How did it go there? Okay. So it's like, if that's the case, then like, what's the point? Like, you know what, if you don't need it, you're really saying I'm creating a new vehicle, but I'm not interested in using it. Like saying what? But this is not the discard. This is actually defining a variable that's called underscore. A discard would mean that so you can't var it. You can't define it as a var. See, now the compiler is happy. So the discard type is a little weird if you never used it before, but it's very convenient, of course. But you can't say var to it. If you say var to it, that's a variable. You can actually have a variable by just the name underscore. So that's what is happening here. So basically what I'm saying, I think here was saying that you're not using this thing, right? Yeah, remove this unused local variable. It's not a local variable, discard. So don't make it a local variable. Use it without the var. So going back to this case, if I didn't want the make, I could say, okay, I don't care for the make, but I do need the model. I'm interested in the model and I'm interested in the year. So you could do that, right? So you're discarding the things you're not interested in to show intent. And of course, you need the var on this end. Yeah, now let's look at the implementation of this deconstruct method, right? We got these out arguments here. How does it actually deconstruct it? Let's look at that. So I'm just going to make sure this application builds. I'm going to copy the code, all of this code. Let's go into sharplab.io and paste all this here. And let's look at you see here, this is our code, and we write the code like this, and it gets deconstructed to these 3 different variables here. What's really happening is it's calling the deconstruct method for you, and it's declaring out variables here. I think language design, if you're good at that, would be really cool, right? To come to think of the syntax arriving at, of course, these days in C#, the design is not done in isolation. It's if you're interested, you should participate as well, since it's open source. I just think it's interesting the way they say, okay, I wish we had a feature like this, and then you kind of go back into it, right? You go backwards to figure out how am I going to implement it, at the compile time from a coding perspective. What should it look like? And what should happen, compile time, what happens after compilation, like type erasures and stuff like that. So here what they've done is they've declared 3 variables. They use them as the out arguments here for the out modifier for this method. And of course it comes back and then they just declare the values have been assigned here. So that's cool. And everything else goes on as usual. So this one line here translates to that internally. And this is the other beauty with C# and maybe other languages as well, where in this case, because of the C# lowering feature, the actual runtime can still be an older runtime. One of the things you should look at here is, for example, and I'm really actually, yeah. So yeah, I normally set this to C#2 here, because if I did the same thing, let's see. The loading idea of C# loading is to lower the code down to a lower version of C#, right? Because all the new features are, for the most part, are simply compiler magic, syntactic sugar. At compile time, it goes back to being the way it used to be, C#2. So if you look at here, if you look at this value tuples thing, maybe it's not going to be visible. But if you convert this to, let's say, C#8 or something, it'll be very different, right? So in C#8, it becomes like that. And this still won't make sense to a whole lot. This is what we've seen before. But in older versions of C#, it actually becomes like this. So actually, that's the wrong method again. Yeah. Anyway, all I'm saying is that these tools, depending on what version they're sort of decompiling, reverse engineering it from and back to, the output might be different. So you might want to play around with to see like how it all looks. But that's the sort of the point I was trying to make, is that all C# loading is trying to do is lower your higher level, newer version C# to a lower version C# and then compile it, right? So it's not like the compilers to learn new tricks, but the compilers already have the runtime and the jitters don't, right? So the C# team can work independently of the runtime team, not requiring the runtime team to support a new feature in C#, since all it really is compiler magic, right? So that's all I have for today. I hope you've enjoyed yourselves. If you have, please give me a thumbs up. If you haven't liked my videos, please give me a like, and I will see you next time.